Welcome, everybody, to another OpenShift Commons community meeting. And we have some very special guests today. Today is Wednesday, November 15th. And last week was KubeCon. Feels kind of like a lifetime ago now. But it was a great fun-filled week, and we wish all of you were there with us. Some of you were. But I'd like to start off with, as people are still joining, like just start with introducing our special guests. We have David Eads. David, would you like to introduce yourself?
Sure. I am, senior principal software engineer for Red Hat. I've been working on Cube since before V1. I'm a tech lead for API machinery and auth. On the OpenShift side of things, I tend to the control plane and have a strong interest in producing a quality product release after release. A lot of work upstream and downstream.
So you can imagine David also gets yelled at a lot. Maybe not yelled at, but he helps keep things going. And Scott, would you like to introduce yourself as well?
Sure. I'm also an engineer in OpenShift. I spend a lot of time focused on product lifecycle topics, and so one of the reasons that I attended KubeCon this year was to sit in on sessions related to upstream efforts around LTS, and I'm participating in the LTS working group there. I think I mentioned I spend a lot of time doing everything we can to make sure that upgrades are easy and painless in OpenShift, and so that's my area of focus.
Thank you. So get your questions ready, and I love that you said easy and painless, Scott. And there's nobody on this call that's ever had trouble with an upgrade, but Scott does a lot of work to make sure that it does go more smoothly and painlessly. Okay, well, let's go ahead and get started, David. If you want to go ahead and kick it off.
Sure. So orchestrating innovation, that's what we do here. We're all doing something different, but we are here and part of the community so that we can share the techniques and technologies that we use to make it possible. We're working with different constraints, building on different infrastructure, and we're pursuing dozens of different goals. I'm not sure whether the people on this call are trying to invent entirely new kinds of businesses or whether they're trying to streamline existing businesses to fit into a budget. A lot of times we'll see people trying to build the smallest possible cluster for the far edge, or they're trying to take an entire data center and put it under Cube to make a build farm. Or maybe the people here are trying to run dozens of different clusters across multiple different clouds, trying to keep them all compliant and stable so that their production workloads that are already there keep running. We're all trying to make something different, but when we find a way to play together, our impact multiplies tremendously. We're all trying to make music together, but if we're not careful, we'll make noise instead. In order to be effective, we have to simplify, select, and combine the things that we're making so that people can use them. It's one of the hardest things that we do, and it doesn't always lead you where you would expect. Take long-term support, for example. That project recently put forward a great design that actually will make upgrades more reliable. The key insight here is that they're going to split upgrades into two parts. One where you're upgrading the binaries, and another part where you are enabling new features on your timeline when it's convenient for you. The idea is to make upgrades themselves safer so that you don't end up stuck on a single version hoping that it stays supported. Another great example here is Cell. So Cell started a common expression language for those that don't know. It started out as a way for platform extension authors to be able to have better validation for CRDs. But what we've started using it for now is to actually improve operational reliability. It's now gating for webhooks so that webhooks are safer to use in production and the blast radius is smaller should they fail. Another spot where we're using Cell is down in authentication. It's being used to make it easier to integrate with the IDPs that you have already deployed in your topology, so that you can integrate with Kubernetes the way that you want it. And we're going to introduce even more in 2024. That actually came up at KubeCon, so late breaking. We're building this core technology, and it's unlocking and applying to all sorts of areas, and it's areas we didn't even think of to enable that next leap in capability. And one of the biggest drivers of that capability are platform extensions. And these are projects that are growing outside of Cube, and they're big, and they can share back and forth, and that sharing is a huge multiplier for us. We had 2 projects recently go V1 this year. One was KubeVirt and one was the Gateway API, and they're both great examples. So when you look at KubeVirt, they are learning from Kubernetes, bringing in things like automated performance testing, where they're going to use that to ensure that the next release of their product performs about the same as their existing release, which is great. And you see benefits in the other direction as well, where you have Gateway API. And Gateway API has novel needs. For those that don't know, I guess Gateway API is bringing together multiple vendors for cluster ingress under a single client-facing API. And when you do that, one of the problems they had was, how do clients share particular secrets with these vendors and with these integrations in a safe way? And so at KubeCon in Amsterdam, we actually started a conversation with Rob Scott and SIG Networking, trying to figure out what sort of new authorizer would be needed. And I'm really looking forward to what we are going to make in 2024. But we wouldn't have thought of it without them. Everyone's making their technology for different goals, but when we combine these projects together, our limits are really extended and entirely new possibilities open up. And what would you use the capabilities for? Well, in 2023, I'd clearly say AI. The question is how. And you can really see the community come together in many areas in this particular spot. So you have SigNode, for example. SigNode, if you look at an arc over the last few years, has been trying to bring ways to leverage novel hardware in Kubernetes. So things like GPU support were already added, but in the past year, you've also seen Device Plugin Manager, and you've seen the Dynamic Resource API coming just very recently. That's going to allow us to run these new sorts of AI modeling workloads or training workloads faster. At the same time, we have Kubernetes workload evolution in, say, the Batch API. That's innovating even today. We can see pieces like the index job support coming in and new failure mode handling so that you can run your training more effectively. Concurrent to that, we actually have new scheduler integrations happening. Projects like Q are coming on and saying, how do I handle entire batches as a concept to be scheduled so that I can finish my job faster and not just my pods faster? And at the same time, once you've finished modeling, you have to have a way to serve that model. And here you can see extensions building on extensions, projects like Kserve building on top of Knative to make this easier and faster. We're trying all the paths at the same time, and we're each adding our own melody. And that's the real power of the community. There's no single conductor. We're trying all sorts of solutions to all sorts of problems, and we're sharing them with each other. And doing that, we can recombine them in novel ways to produce new things. You occasionally get that crazy aunt that sings a little bit off key, but it could be she's just got the next melody. So come join us and let's build something new together. And I won't be at the booth, which is how I closed the last one, but I'm happy to be here to take any questions that someone has.
I mean, I feel like we should give a standing ovation, but I can't tell you how grateful I am for David and all the work that he does upstream. So please, right now is your time for any questions for David before we keep moving on. Now you packed in so much information in those 5 minutes. Go ahead.
I was going to say I'm happy to take questions, throughout the call if they come up in the chat. There was a lot there. I think I went a little bit long this time because I thought you wouldn't cut me off. But it's an area I'm really excited about, and there's a lot of projects that come together that where you really do see, oh, I made this piece of core technology. I made it for this purpose. Someone else is using it for something else, and that's awesome. And Karina said that there were cases where a lot of people were yelling at me. Most of the time, it's not quite yelling, but they are telling me, David, I really need this because it'll unlock these things. And it ends up unlocking so much more once you manage to get it delivered.
Speaking about unlocking, do you want to talk a little bit more about Cell? I know that's one area that you're super passionate about and how it enables more work.
It is really, really great. And a lot of people aren't quite clear on why we chose it. So there are lots of ways we could have chosen to allow people in an API to describe some sort of expression to be run. But the cost estimation, bounding, and safety in Cell are really what made it the best, right? It's not Turing complete, which is good because we know we can estimate how long it's going to take to run. And it has proven to be powerful enough to solve many of our use cases without being so powerful that we can't turn it on. And so it is a tremendous multiplier. Now, whether we'll end up doing something else to describe some sort of GraphQL for an advanced authorizer, I don't know. Whether we'll use Cell to try to generate that graph, well, that looks really likely to me. And yeah, I'm really excited about that one in particular.
Now, we also talked about, when we were prepping, we talked about KubeVirt and what you've been enabling, what you've worked with others to enable in Kubernetes itself for technologies like virtualization, KubeVirt, and the storage that backs it up. Would you like to talk a bit about that? I found that one really interesting.
Yeah, it's surprising how much, when you start down the rabbit hole, how much you actually end up needing, right? So KubeVirt ends up, the actual deployments of KubeVirt that you see end up relying on a lot more than just, can I start a VM? Like you'll see integrations where they want to go deep in networking. And they want to be able to program a networking layer. I can't remember the name of the little card that they actually want to program stuff on. You also see areas where they are trying to move tremendous amounts of data around. And that leads to things that they need inside of storage for reuse, for backups, for efficiently moving from node to node. I don't know if anyone here runs KubeVirt, but you end up discovering you have a lot of locality based on your data because it's so expensive to move. And so actual deployments of it get really interesting to look at.
Now, I haven't seen any other questions in the chat yet, but what are you really excited about?
So I'm torn. Like there's the stuff that I know is going to be valuable, but then there's also the stuff that like looks really, really cool. But I'm not sure how we would do it. So can I choose one of both? One of each? Okay.
Yeah.
So probably the thing that I am most interested in that has some sort of like defined how we would do it. Is this idea of what would a new kind of Go client for Kubernetes look like, right? Right now, you have two that are fairly popular. There's controller runtime, and then there's the core Kubernetes clients. But they both suffer from a problem, and that problem is that they carry a dependency on the APIs that you're going to interact with. And it's not as obvious inside of controller runtime, but it's still present. They depend on a particular level of API machinery. And by doing that, it means that every API you're trying to embed has to agree on a particular level of kube. So if you want to depend on a KubeVirt API and a pod, or you want to depend on an OpenShift API and a pod, or any combination, they all have to agree on the level of kube. And then once you have that level of API that you want, you have to use that version of the client. And it's actually really difficult then to introduce any sort of changes into the client API. I don't know most of the people on this call, but if you've been here for a while, you might have lived through and now we're going to add context to every call in the client. And that was absolutely the right choice. I stand by that on the technical front, right? The ability to have cancellation run all the way through the client down to the HTTP stack is absolutely the right choice. It was brutal for consumers because they had to find a level that agreed for both, and they had to update all their consumers at once. I want to try to make a client that doesn't do that. I want to make a client where you can pick the API level that you're going to use, and you can mix and match. You could have a 129 cube and something for cube for this more recent 130, or older 127, right? Whatever combination makes sense that you can add, you would be able to leverage those together. And I think by doing that and actually versioning our client independent of our APIs, we'll be able to make future transitions like that a lot easier. And that'll make us less afraid to actually improve our clients, right? There's some long-standing issues that we haven't fixed, in part because we don't want to break everyone again. So that's sort of concrete. We know roughly how to build it, and we're fairly confident that we can. The one thing that I'm interested in where I'm not so sure we're actually going to be able to build it, but the power behind it would be amazing, is if we could actually find a way to make new pod use cases possible, right? Like, so I named out a few that Signode is doing now, right? Device plugin manager, dynamic resource allocation. Like, those are very popular things, but they're narrow in the sense of that you had to get an upstream project to actually include it, and then leveraging it is actually quite difficult. I don't know how many people have tried it. Probably not that many because it's alpha and it's like pretty niche in Intel, NVIDIA land. But what if we could find a way to make that sort of innovation happen outside of CoreCube? I don't know offhand how we would build that. I don't know what that would look like. But finding a way to do that so that we could enable those use cases to be developed, let those people build what they want as though it were a platform extension, but not have the rest of the Cube ecosystem pay for the complexity, would be tremendous in my mind. And I don't know how to do that offhand. I do believe it can be done. And if you're interested in doing it, we should absolutely talk either here or in an upstream SIG-Arch for ideas of how to make that happen. So that was really long-winded. Thank you for letting me do too.
I kept thinking, I bet Scott's thinking about all of that and how he's trying to work on life cycle while you're doing all the API work. Those were some of the thoughts that I had while I was.
I'm sure Scott will thank me.
Yeah, I think we're certainly benefiting from a lot of the decisions that have been made upstream as to how we handle API removal, beta APIs. I think, the past maybe 2 years have been pretty rough for folks because there were some pretty significant API removals. But also there's sort of a light at the end of the tunnel, and that, like Cube 124 doesn't require any beta APIs to be installed just to run a cluster, whereas previous releases did. There's also new policies put in place that say any beta API will be deprecated and removed within 6 releases, and then the last on by default beta API should be removed in 129. So hopefully around APIs, we're sort of on the off ramp of some pretty rocky adventures around beta APIs that became incredibly well ingrained in everyone's uses, and but hopefully at this point that's less of a problem than it was. Cube 122 removed a bunch of APIs, CRD v1, and that one in particular was pretty rough, but hopefully we're sort of past that at this point.
I wonder if this might be a good time to talk about, and we do have a couple of questions, but I was going to mention quick is the Go changes that happened earlier this year in 2023 that made it easier for these API changes, or Or we could talk about that later.
Sure, we can touch on that. So I think the biggest change that we saw in Go in the past year has been the way that defaults and compatibility modes are guaranteed. It's more compatibility modes. Compatibility modes are guaranteed by the Go compiler. And so again, I don't know how long most people on this call have been here, but one of the things that you might remember is the great cert invalidation that happened when Golang said, well, this mode is insecure. We are not going to honor it anymore. And suddenly you recompiled your project and redeployed, and certificates that used to be valid were no longer valid. In my mind, I think this was a good choice for security. Again, like it's sort of one of those, I can stand by the people that made it and said they made the right choice. As a consumer of this, it was terrible. The problem that you faced around, well, great, now I can no longer build my project with a supported level of Go. What am I going to do if there's a Go CV, like say HTTP2 reset? So you would really be trapped in that case. The changes in the Go compiler to say we will have a compatibility mode that supports back releases so that you can build using a compiler that is valid or that is supported is a huge win. So it still relies on downstream projects making good choices with their APIs, but I'd say that's the biggest change Golang made for us.
That's also sort of a key enabler of LTS, in that, you know, when each version of Cube shipped in the past, it was locked to one version of Go and never updated. Therefore, the way that Red Hat has supported things for a long life cycle is that we have to continue backporting a bunch of fixes into Golang itself. And now, you know, we get to a place where if we continue to move forward like upstream is, we won't have to do that for as long, depending on how long, you know, our ultimate life cycle is. Whereas in the past, as soon as something was over a year old, we suddenly had to maintain Go on our own, which is a challenge for sure.
Doable, but a challenge. Ooh, I can see the chat. Can I jump into the confidential containers thing? So I don't know Dwayne, but I am very interested in what you're using it for. The idea of being able to trust that your containers being run unmodified on a cloud is a really powerful thing to be able to do, and I think it's pretty much essential to be able to move many workloads into the cloud. I'm actually less sure of its applicability to the edge, and that's probably just me not knowing how it would be deployed in there, and like what the challenges to trusting the underlying layers would be. But I do believe there is a future in that project. I think it's a good one to be invested in, and you see companies like Azure bringing it up because I'm sure their customers are saying, like, I can't move until I know for sure I'm running what I think I'm running and that the access is what I think it is. Yeah, by all means.
Yes, thank you so much. I also wanted to know, you know, I was thinking about it in terms of maybe with Kafka and, you know, the sensors and all of that, and just trying to, you know, the edge is supposed to be the hot, you know, a hot complementary thing to the rest of OpenShift. So so just trying to, and they say that the TE is sort of like a hardware thing, and I was like, ooh, isn't that a little going out of our boundaries? But just trying to see how that would affect everything.
I can see it being valuable. I think that people who I'm used to seeing it more for cloud use cases. I can see for the edge use case, if you were really concerned, well, I guess actually edge customers probably are really concerned about being sure that every layer of their stack is signed and is running exactly what they expect. I think it can be really useful. I haven't built out an edge deployment that has it myself, But I did see like, yeah, like I said, Azure bringing it forward recently, and you know, I'm glad to see it. There was one other thing that did catch my eye here in the side chat is a new business model for development, upstream and downstream. I don't know what it would be yet. I'm assuming this is talking about like how you would actually change a pod lifecycle. I don't know what it would be yet. I don't know how we would build it yet. But you know, like before eBPF, people didn't know how to do that in the kernel either, right? So like someone is going to figure it out, and I think that the sort of things it would let us do, especially related to custom hardware, would be huge.
I just saw that Steve left the meeting, and if he watches this later, sorry, he couldn't stay for a longer LTS discussion. But talking more about the upstream downstream synergy, I know when I've worked with a lot of customers, it was helpful when I would explain and describe more how we do work upstream and downstream, because a lot of the times we take it for granted, being at Red Hat and doing what we do, and a lot of us that work upstream. So I wonder if either of you, both of you, want to talk about how you do work upstream and then how it lands in the product. And I know, Scott, a couple of years ago, we went through these presentations as well. Maybe we'll look at reviving those, but what do you think?
Yeah, specific to how things go upstream. I would say, you know, one of the things that Red Hat has always sort of done across even RHEL is we sort of have an upstream first approach. And so whenever we get a bug that we need to fix, or maybe a feature that we need to develop, we, and in almost all situations, try to push that feature or bug upstream first, and you know, make sure that it's accepted upstream. And maybe if it's only accepted upstream in the master branch or something like that, or the main branch, you know, maybe we backport it a little more aggressively than upstream does. But we want to make sure that in the long run, we're not diverging from what's happening upstream. And it's better for everyone if Red Hat and OpenShift doesn't have to maintain a huge set of patches that are unique to Red Hat products or OpenShift. And so certainly, you know, I think pretty much everything that we try to do upstream first. I'm not quite as deep into upstream projects as other folks in OpenShift, so I don't know, David, if you had anything to add to that.
A little bit. That's a great lead out, and I guess I'll also throw out, I mean, I don't know if I'm supposed to or not, but if I were a consumer, I would look and say that alignment with upstream is critical, because should for some reason I need to move, I'd be able to. And I had, yeah, maybe it's good Steve isn't here, but like I see that as actually good. Like it is good for the client. One of the other key things that we do upstream, a lot of the reason that we spend and invest time in many of the SIGs in Kubernetes is so that we can be that voice of not all customers are at the leading edge. We need to be able to help people get where they're going. We need to be sure that everything else continues to work as people expect as best we can, and also how we can guide consumers in a way that will allow many projects to flourish. And so one example of an upcoming project would be something like CRD schema checking, right? Everyone uses CRDs, but there's really no mechanism for guiding people in the evolution of their schemas. And how you shape a schema matters greatly. And I think when a lot of people think about Kubernetes, they can think of the fact that they had a pod, and maybe they have the same pod they had back in 1.6 or something when they came on. And the reason that's possible is because we take great care. But care in developing the API, not like David, Jordan, Daniel, and Tim don't scale. And trying to codify that, I think, is an example of a project where we're looking and saying, like, this is where we're guiding us to. And for an LTS to work, we have to be able to span all these releases. In order to do that, let us guide you so that you can make something that'll do that. And I've realized I've been talking over other David for a very long time now. My apologies, David. I'll yield.
I'm assuming you're yielding to me.
There's a David E. Ebery with a hand up.
It's both
Yeah.
David.
There's two of us here. I just have my phone on because it makes it much easier to type and such when I have my phone on and listen. I'm going to be the thorn in some degree side, Mr. Eads. On your your information and what you presented, is that cloud based or can that be on-prem based or both?
I've talked about a lot of things. Sorry.
With your API, which you presented in your slide deck.
Oh, so
is that primarily for Amazon, Azure, and everything on the cloud, or can that be on-prem? I say that because I'm probably one of the 5%ers that puts everything on-prem because of we deal with a PCI.
Your data is your data. I mean, or at least that's how if I were a sysadmin, that would be like my point of view. My data is my data. So the AI stuff, I think that it is valuable everywhere. It is valuable for someone who is looking to be able to say, I need to train my model, and in order to do that, I am going to buy custom hardware, but I only have a limited budget, so I'm not going to buy like infinite custom hardware. I'm going to buy a certain amount of it, and how do I then leverage it? And that's what, say, the node features are for. The workloads and scheduling features are complementary, and so you can look at them, and it's primarily around if I run a big enough job, I know that pieces of it are going to fail, and whether that's due to hardware failure or network failure or coding failure, I know that some of it's going to fail. How can I fail more efficiently so that I can use that limited hardware that I have effectively? And then something like a scheduler says, you know what, you got one more pod to finish this job. I'm gonna fit you in here, even though it'd be more efficient to bin pack something else, because pod wise to finish it. Because once I'm finished with you, you'll finally be able to use a result, right? And that's what matters to you. And so I think all those things I mentioned are valuable for all the consumers, not just the clouds of the world.
Okay, I'm just saying that because a lot of people are, going to the cloud, and to some degree, our side is like, we don't necessarily want to go to the cloud because we want to control the data and who accesses it and security standpoint.
Absolutely. And so these constructs are going to help everyone. Now, some of them are narrow, right? So if you aren't using NVIDIA GPUs, how much benefit are you going to get from a dynamic resource allocation API? Not as much, because they aren't there. Other vendors, as far as I know, other than Intel and NVIDIA, aren't there providing integrations, right? So there's nothing specific about the feature, but the hardware you use will control to some degree how much you can use some of the advanced node features. But the batch API features, the scheduling features, and the serving features, no, they're going to benefit everyone.
Thank you.
So, and Scott mentioned batch workloads in the chat as well. Scott, do you want to talk about that? What was talked about at KubeCon?
I think David touched on it there as well. Like, there are certain workloads that 99% complete is 0% complete. And so that's anything that we can do to make sure that every, 100% of the batch is complete before something gets rescheduled, that will improve batch workload outcomes. And AI workloads, training, all that seems to be very batch driven. And so the scheduler stuff that David mentioned, I have some notes on this, just trying to read them really quickly, see if there was anything that really stood out. But I definitely attended that session, and I guess maybe one thing is, the schedule for KubeCon is out there, and if you click into a lot of these sessions, you can find the decks that people used. And so there is a batch working group session that I don't have any big aha moment from it, but certainly, it is a topic that's the scheduler folks are looking at.
I do think index jobs were really, really big when they came. They are in at least beta now. There were some additions that we made for error handling. Trying to have better failure mode handling was a big thing in 129.
Yeah, that was called out as what happens if one pod fails.
Yeah.
And 129 is being released in a few weeks.
Yes. Yeah, it was alpha in 128. Yeah, it was alpha 128. I mean, there's a bunch of cool stuff in the area, honestly. Like, you let me geek out long enough. There was some new scheduler stuff that came in, making affinity and anti-affinity work better with rolling deployments. I merged that in as an alpha in 129, which, if you've had trouble trying to roll a particular workload because you need to have both node affinity and pod anti-affinity, and you got like pathological behavior on new rollouts, that'd be something to look at.
I'm excited, but you mentioned it's alpha, so don't use it yet in your production environment.
Sorry. Yes, do not depend on it in production, but know that it is coming. The implementation looks solid to me, so I'm fully expecting it to get promoted to beta and stable and standard sort of time frame.
Now, this would be a good time to talk about all the LTS goings on. I know it's a topic, we've kind of touched on it a little bit, but wonder, Scott, if you want to start with what you learned, and then David, you've been working on this for kind of for a while.
Yeah, I think there was an original working group LTS that did a few things back in the 2019-2020 timeframe, where they were able to shift from 4 releases to 3 releases a year and expand the overall life cycle of support up to about 14 months. And in KubeCon EU, which I did not attend, there was sort of a revitalization of working group LTS. And since about June or so, we've been meeting again. And then at KubeCon this year, there were, I think, 3 contributor summit sessions. It was brought up in, I guess, both David's keynote, and then also Jeremy Rickard from Microsoft had a keynote session that specifically focused on LTS, where he cited, a lot of data from analytics or Datadog and other companies that show basically, I think, somewhere around 60% of clusters are running versions that are EOL upstream. So in the contributor summit sessions, the VMware folks led one of those, and they presented, what seems to be general alignment around, at least AKS, EKS, VMware, Tanzu, I guess, and OpenShift were all sort of coming pretty close to upstream plus 12 months as our, fully disclosed LTS or EUS policies. Red Hat's a little bit different in that we have 18 and 24 months, whether it's EUS or non-EUS. And it also seems like there was probably likely to be some alignment that after the first year, if there is any sort of upstream effort to continue support, it's likely to be focused specifically on CVE fixes. But then also, a lot of the sessions there focused on topics around making upgrades easier. Jordan had a session in the Contributor Summit that was specifically on remaining up to date, where he recounted some of the API changes that I mentioned earlier. He mentioned the Go compatibility changes, and he also made mention of the compatibility mode stuff, that basically what's happening in Go being replicated potentially in Cube itself, to where you could imagine upgrading the binaries. However, that ends up happening between multiple versions, but still having a cluster that essentially maintains compatibility with the version that you came from. And then once you've upgraded across multiple versions, flipping over into compatibility mode, or flipping into the newer versions compatibility mode, so that you will more effectively go from 118 to 121 without a lot of intermediate steps through other compatibility levels. I don't think Google has publicly announced what their plans are with LTS, but AWS, Azure, Red Hat, VMware, we all have that on the books. And seems Jeremy mentioned in his keynote that AKS went LTS with 127, and EKS, I forget exactly, I think they did 127 as well. And so they're all sort of forward looking at this point. And I think at this point, Red Hat and OpenShift, we've done a few of these. So we certainly shared some experiences in the past meetings about what we've seen. AKS seems like they're going to pursue a path where not all versions will be LTS, whereas EKS, it looks like they're likely just to have all versions supported for an additional 12 months. Certainly, supporting any versions longer creates strain on the ecosystem. So efforts like the Gateway API will have to decide whether, when they shipped and they depended on CEL, did they have to make special accommodations to support older versions that people have declared LTS, or do they say, sorry, only non-LTS versions are compatible with our new thing? Certainly the ecosystem will have to sort through that to figure out, what the right thing to do is. I think one of the main things is that we're pushing for folks to fill out a survey around upgrades so that we better understand where people are, where the challenges with upgrades are. And so that link that I just put in there is the link to that survey. I think it's going to run through end of year. We've already had, probably 100 or so responses, and we're certainly looking for more responses. And so hopefully that feedback will help us better decide what the community pursues here, because I think at this point it's not really clear what the community will do. And so it was still sort of probably operating in a mode where every vendor's got a slightly different thing. And I'm not certain that every vendor being slightly different is a bad thing, but if there's certainly areas that we can align upstream, I think we should pursue that. Just looking over my notes to see if there's anything I missed. I think I covered it.
So LTS, long-term support, that means something to many different people, right? So it could mean, how are the applications being supported? How are you staying on a certain level for a long time because you just don't want to upgrade, or you have specific pain points? And I know that David and others upstream have been working on skip levels, which we haven't really talked about a lot yet. I wonder, David, if you want to jump into what that work means and for the problems that people have had that have prevented them from upgrading.
Sure. So Scott touched on it, right? One of the things he talked about was how can you avoid a situation where you stay on, you love OpenShift 4.12 so much, you just want to stay on it. And suddenly you decide, okay, I need to go to OpenShift 4.16 or 4.12, 4.14. And you say like, okay, now I need to upgrade. And when you do that upgrade, how can we make it as minimally disruptive as possible? And where disruptive probably means taking an application down. Now, I will tell you, my very first thing to tell you is you should write your application such that it can tolerate having a node go down. And I don't even have a but for that, right? Like, hardware failures happen, network partitions happen. Like, the app needs to be able to survive. So that's the first thing you do. The second thing that you can do is to say, like, okay, how can I bring you all the way up to date all at once? That's part of where you see efforts around, like, I want a kubelet n-3 sort of thing, but that doesn't get you all the way, right? And so skip level upgrades can dramatically assist you in the speed of an upgrade and the number of levels you have to certify on in the middle, right? So if you're going to 4.14, right? Being able to say, well, my app runs on 4.12 and my app runs on 4.14. I never want to hit 4.13. Well, that's of value to you, right? So a skip level upgrade can really help there. When I think about LTS, one of the things that I worry about the most is being sure that the vendors remember that they serve the community and the community doesn't serve them. And so finding a way to keep incentives for Cube moving forward, where you look and say, I want to improve life a year from now, as opposed to, if I make this change, I have to support it for 3 years. I'm never refactoring this component again. Trying to keep trade-offs like that in the balance of let's move forward to enable something like a next evolution in a node, I think is critical for the community. And I have confidence that we will navigate this one well. But I think skip level is a pretty clear win for the examples that I described.
Do you have opinions about skip levels, Scott?
I think we'll probably get there in some form or fashion, but I don't think that we'll likely get there in a manner that is likely to enable someone to upgrade effectively once every 24 months. I can envision getting to a place where you can skip 3 versions, but probably not skip 5 or 6 versions at once. And I think, it's certainly going to be a challenge for anyone that even, you can certainly upgrade a cluster multiple times across those versions and achieve that in a decent time frame. But I think the amount of change that happens over those 6 releases is a challenge for anyone to consume at one time anyway. Certainly in on-prem scenarios, sometimes you might have to do things like upgrade your vSphere environment or upgrade your NetApp environment to maintain compatibility. So there's external integration points that also need to be considered when you upgrade. And so I think finding the right balance of a sustainable upgrade pattern is probably also valuable here, so that we're not, encouraging people to attempt an upgrade across 2 or 3 or 4 years of Cube versions at one time.
Yeah, I agree.
So we'll get better, and we'll get to a place where, you change the denominator a little bit, but I don't think we're going to get to a place where you skip many versions at once.
I'm impressed with how much you've already changed upstream to enable even changing 1 or 2 versions. I mean, that's
Well,
huge.
to be clear, what we've done so far is wider kubelets queue so that workflows aren't disrupted. You still upgrade your masters twice, right? And we have a nearly agreed upon plan that will make the next step possible. We haven't done it yet, right? Just so we're clear, Han is currently on vacation. He doesn't get back till after Thanksgiving.
So you're saying 1:30?
I know that he is eager. He and I spoke at KubeCon. He's a Googler. He and I spoke at KubeCon. It's his design, and he's eager.
That's awesome. So we'll have 7 minutes left. So quick time check. For the community, we have Scott and David here. Is there anything that you're excited about that you heard about from KubeCon? Johnny, I know you were at KubeCon because I saw you. What struck out to you that was exciting?
Yeah, so there's just a bunch of like observability projects that are coming out that I think are going to be really interesting. There was a lot of technology that people had. I think as people are, you know, in Dave's example, right, where he's on-prem and he's bare metal, I think that a lot of these companies are going to get bit by being a SaaS only, especially for companies that are on-prem, because maybe they can't reach out to the internet for some of that stuff. So I'm curious to see how they're going to adapt to it, because they have some awesome tech and like what they can do and how deep they can go within like the infrastructure and look at things. So I don't know. I'm kind of excited about that, like some more observability tools, and you know, really just kind of seeing how they mature when they see that their customers aren't all in the cloud, as David had kind of explained. The other thing is that the Helm stuff that we talked about, right? Like our team is very, very heavy in Helm, and yeah, so just kind of anxious to see what comes out, and you know what the next releases are going to hold, and hopefully see the whole ecosystem kind of get better and get easier to use.
So in the Helm talk, we talked about Helm 4. So which is not out yet, which we're in the beginning stages of planning. So if you want to talk Helm, come to the weekly developer calls, which are Thursdays at noon, but feel free to reach out. So Johnny would love to have you there too once we start, or even now, but once we start talking about Helm 4 and requirements and things like that. So yeah, thanks for bringing that one up.
Yeah, definitely. And one last thing I just thought of, and I know I see David getting excited because he was like right behind me in the talk. But yeah, the other thing that I was really excited about is we did a workshop on Argo rollouts, and if you're not familiar with Argo rollouts, it's such an awesome feature of the Argo CD project that allows you to do progressive delivery. So if you've ever done like blue-green deployments in OpenShift or even on just raw Kubernetes or even canary testing, you know that there's a lot of effort that goes into making those you know, work and, you know, valid for your environment. And Argo rollouts just simplifies the whole thing, and it is super rad. So if you get a chance, check it out, and if you have any questions, hit me up. That's it.
I was just going to bring up for Helm 4, think about CRD schema evolution. Saying you can't change it is pretty severely limiting. Thinking of a way to make it so that you can change it, and I think that's going to be important, along with probably some mechanism for saying, I want to be able to manage the validation for this type from this Helm chart, but not these other ones, to try to prevent accidents where you are overly broad in integrations like hooks and validating admission policy. So, David's wish list for Helm 4.
I can't wait for you to come join us in planning. I mean, all are welcome. Yeah, I mean, we'll talk more about that for sure. Thank you. So we have 3 minutes. We don't have to use them all. I'm not going to keep everybody, but it was a fantastic KubeCon, just general observation. It felt more like, I think, KubeCon of old, if I can say that, where a lot of the hallway track and the contributors getting together. I thought there was a lot more, there were more discussions going on. Maybe that's just my own observations, but it felt nice seeing everybody getting together and talking about these technical problems and discussing potential solutions. And I think that will only help get features into Kubernetes faster that we need, or that will help the overall ecosystem. So those are some of my general observations. Do you have any as well? Anybody?
On interesting topics and sessions, like I attended the Open Telemetry. It was cool to see that they were taking logging to GA, and they seem to have a very high standard for what they call GA there. I attended sessions, a lot of sessions around CAPI, and Red Hat's trying to move to CAPI, both for machine management and possibly for other areas of the product. And so they had some presentations where they were able to scale up to managing around 2,000 clusters without blowing up their SLAs or anything like that. There were some cool improvements around coordination between HPA and VPA to make sure that once you experience a burst of workload, if you scale out and up at the same time, that you could potentially scale back down in a more sane manner. So that'll be interesting for anyone that has bursty workloads. I think that's probably it for my notes.
Yeah, I enjoyed it. There was a lot of contributors getting together and talking. A lot of the talks were, "Hey, look, we can do this this really cool thing, and here's a link for more details." And in a lot of those cases, if you drill down, or if you're familiar with the project, it's great to get that opportunity to go talk to the guy on stage afterward. And people were great about sticking around and doing that. And there were a lot of people willing to tell me what I had done wrong in API machinery over the years. Not yelling at me, but very politely telling me, "You should do this." So
That's the beauty of community and collaboration and being upstream.
Yeah.
And Piotr, it's so good that you are here as we're closing out the call. Haven't seen you in a while, but anyway, I didn't mean to call you just as you're joining, but welcome. It was a great discussion, and do we have the times off? You look confused. And we can stay for I can stay for a couple minutes. So
I gotta drop. But good to very briefly see you, Peter.
Oh, you're speaking about me. Hey guys. Sorry, my audio was off when I was joining, so I didn't hear what you were talking. So, but I heard my name. Hey, nice to see you.
Nice to see you. Piotr is a longtime community member, and we thanks, Johnny. We just had a great discussion, and maybe it's the time change, but I'll send you the recording and everybody else here. But we'd love to have you on next time too. No, my times are off. Thank you everybody for joining. I'm going to stop the recording, but I will stay on for a few. Thank you all.